Hello everyone, welcome back. Hope you all are doing great. Guys, today in this video we are going to understand troubleshooting. We are going to troubleshoot one ticket of BGP, and you can see ticket is what, problem is what, PCs are not able to communicate with servers, right? So see guys, in this scenario I have few routers like router 1, router 2, router 3, router 4 and router 5. Router 5 is connected with one LAN with one local area network where we have some servers like file server, DNS server and HTTP server. And here we are running this network 192.168.10.0/24. And here we have router 1 R1 is connected with two LAN. You can say this is LAN 1 local area network 1 and this is LAN 2 local area network 2. Let's say this is in different location and this branch is in different location. Fine. Now guys, in LAN 1 I am running this network 10.1.1.0/24. In LAN 2 I am running this network 10.1.2.0/24. And on router number 1 we are running BGP AS number 65000, and on router 2, 3, 4, 5 we are running BGP AS number 65001. So between router 1 and router 2 we are running eBGP neighborship. In the same way between router 1 and router 3 we are running eBGP neighborship. And under ES number 65001 we are running IBGP full mesh neighborship. Like router 2 will have neighborship with router number 4 as well as router number 5 as well as router number 3, right? So router 2 will have three number of IBGP neighbor and one number of eBGP neighbor. Like router 1 is eBGP neighbor and router 3, 4, 5 is their IBGP neighbor. In the same way on router number 3 also we have one neighborship with router number 2, router number 4 and router number 5. Getting my point guys? On router number 4 also we will have three IBGP neighborship with router number 2, router number 3 and router number 5. In the same way router 5 have three number of IBGP neighbors, router number 2, router number 4 and router number 3, right? So this topology is pre-configured. BGP is already running there, right? After that, after configuration of BGP, these PCs are not able to access this server, and as a network engineer you need to troubleshoot it. Fine. So guys, we are going to first verify the problem and then we will see the troubleshooting. Okay, so without wasting our time, let's begin. So here I have access of all routers. On router number 1, you can see show IP interface brief exclude unassigned, right? Exclude so IP interface brief exclude unassigned. So see, on this LAN interface fast Ethernet 0/0 which is connected with switch 1, I'm running what IP here, 10.1.1.254, last IP address of this subnet. In the same way on fast Ethernet 1/0 which is connected with switch number 2, I'm running this network 10.1.2.0/24. And you don't need to focus on the network running between routers, like between router 1 and router 2 what network I am running, right? This is not your concern. We can run any network, right? Our requirement should be what, there should be reachability between loopback to loopback, correct? Like between router 1 and router 2 both loopbacks should be reachable with each other. In the same way between router 1 and router 3 both loopbacks should be reachable with each other. Okay, so from router number 1 I'm going to ping 2.2.2 and say source 1.1.1. so you can see there is reachability. In the same way if I am pinging 3.3.3, so you can see I have reachability, right? Now guys, let me verify the IP address on servers, or we can verify the IP address on R5 LAN interface. So LAN interface of router number 5 is fast Ethernet 1/1. So let me take you to R5 directly, and here I am going to run this command. So IP interface brief exclude unassigned. So you can see on fast Ethernet 1/1 I am running this IP address 192.168.10.254. So from router number 1 guys, I am going to ping this IP address from the LAN interface, right? Just to check the connectivity between LAN interface to LAN interface on routers. Okay, so let me take you to R1, and from here I'm going to ping 192.168.10.254 and say source is 10.1.1.254, right? LAN IP address. And yes, you can see there is problem, right? That means definitely these PCs cannot ping to servers, because from this interface I am not able to ping this interface, right? In the same way I can verify the connectivity from this interface as well. So from this interface also let me ping from source what 10.1.2.254. so you can see from this interface also I am not able to ping, right? So there is some problem. Now how you will troubleshoot? First of all guys, I am going to verify the routing table of R1 because router 1 should have this network in their routing table, right? So let me do one thing. On router number 1 I am going to check route, so IP route, or I can run the command so IP route because we have lots of prefixes in routing table. So simply I can say so IP route 192.168.10.0. so you can see this network is in my routing table via BGP protocol, via BGP. Routing entry for 192.168.10.0/24, non via BGP 65,000. Correct. Distance is 20 because I am running this network through eBGP neighbor, right? Maybe from 2.2.2 or from 3.3.3. Correct. So tag this last update. Okay, you can see from which router I am learning 3.3.3 means via router number 3. Next hop will be 3.3.3 and I am able to ping 3.3.3 from here, right? So next hop is reachable. So on router number 1 we have this route and we can check BGP table as well. You can see in BGP table I am learning this network from both neighbor from 2.2.2 and from 3.3.3. so IP BGP summary, right? So neighborship is also fine guys, right? And I have received one prefix from both neighbor, right? Or simply you can run this command also for verification. So IP BGP neighbor 2.2.2.2 and route, right? It will show you the received route from 2.2.2, right? So you can see this network. Then this is not best only valid from router number 2. So in the same way I can say so IP BGP neighbor 3.3.3 and show me the route. So it is showing this network and this is best as well as valid from 3.3.3. okay, so now on router number 1 I have route for the destination network. In the same way guys, on router number 5 should have this and this network. So let me check the routing table of router number 5 directly. So let me take you to R5. On router number 5 I'm going to run command so IP route 10.1.1.0, right? And see guys, this network is not in table. This network is not in table. Now why this network is not in table? Let me check routing table of R4, and before that let me do one thing. So IP route here, if I'm running this command so IP route, you can see we don't have any LAN network connected with router number 1, means I don't have 10.1.1.0 or 10.1.2.0. On router number 4 let me verify the routing table. So IP route and 10.1.1.0. so on router number 4 also we are not able to see this network in table, and 10.1.2.0, yes, this network also, right? Now guys, router 4 and router 5 don't have 10 networks. Let me verify R2 routing table. On R2 so IP route, or what you can do simply on router number 1 you can run this command so IP BGP. By running this command you can check that we are advertising these two network correctly in BGP or not. So yes, we are advertising these two network correctly in BGP, right? This network subnet mask is correct and next hop is 0.0.0, right? After that I can check that router 1 is advertising these two network to their neighbor or not. For that I can run command so IP BGP again neighbor 2.2.2.2 and advertise route, advertised route. So you can see router 1 is advertising these three networks to their neighbor. To which neighbor? To 2.2.2. In the same way to 3.3.3 also it is advertising to 3.3.3 or not. So yes, it is advertising to 3.3.3 as well. Getting my point? Now if you don't want to advertise this network 192.168.10.0 to their neighbor because router 1 have learned it from router number 2 or router number 3 only, right? So you can configure the router in such a way so that it should not advertise this network to their neighbor, but by default you can see it is advertising. Now let me take you to R2, because on R2 I have to verify that R2 is receiving 10 networks or not. So IP route 10.1.1.0. So yes, you can see this network is in the table of router 2, right? And next hop IP address is 1.1.1, right? It is learning this network from 1.1.1, correct? Right? In the same way, this network 10.1.2.0, yes, this network is also in table. So IP route BGP, you can run this command also, BGP. So you can see we have both network, right? Now guys, what you can check here is you can check the BGP table, because see here on router number 2, if you will check BGP table, so IP BGP summary, how many neighbor are there of router number 2? 1, 2, 3, 4. Router 1 is neighbor, means router 1 is eBGP neighbor, router 3 is iBGP neighbor, right? Router 4 is iBGP neighbor, and router 5 is also iBGP neighbor. So here see guys, one thing, so IP BGP in the BGP table, when router 2 is learning this network 10.1.1.0/24, it will learn from their two neighbor, from 1.1.1 as well as from 3.3.3. Getting my point? Router 2 will learn this network from their two neighbor, from this neighbor also and from this neighbor also. But from both sides, next hop IP address is what? 1.1.1.1. 1.1.1.1, right? Why? Definitely best is via router number 1, because eBGP is always before our iBGP. But router 3 will not modify next hop IP address whenever it will advertise prefixes to their iBGP neighbor, right? So same thing is happening over here. Router 3 is not modifying next hop IP address, but router 3 should modify next hop IP address, right? So on router number 3, I can run one command, right, so that it will start modifying next hop IP address, because router 3 is my edge router. In the same way, router 2 is also my edge router. So on R3 guys, I can run one command here, router BGP 65001, and then say neighbor 2.2.2.2 and say next hop self, correct? Now let me take you to R2 again, and now I am going to run clear IP BGP star soft in command, and then again I am going to check BGP table, so IP BGP, yes, now this time you can see, this time BGP table looks fine, right? It is learning 10 network from 3.3.3 also and from 1.1.1 also. Best is from 1.1.1. So now router number 3 have modified the next hop address, and same thing is happening on router number 3 also. If you will check BGP table of R3, you can see next hop from both sides is 1.1.1. So on router number 2, I should again modify next hop address for neighbor 3.3.3. So say router BGP 65001 and neighbor 3.3.3.3 and next hop self, right? Now on R3, if you will clear BGP table, clear IP BGP star soft in, and so IP BGP, now you can see BGP table looks fine, correct? Now R2 is modifying next hop address for their 3.3.3 neighbor. Getting my point? So that's why here we are getting next hop 2.2.2 and 1.1.1, and best is again via router number 1, because eBGP is before our iBGP. Fine. So hope till here all verification is clear to you. Now guys, if you will if you want to know some more verification command of BGP here, so what you can do, you can run this command, so IP BGP again neighbor 1.1.1 and not advertise prefix, received prefix. From this neighbor, what prefix I have received, so received, and then we can say what, route received wait, simply I can say route here, right? Route, it will show me display routes learn from the neighbor, right? So I can say what here, routes. So you can see from this neighbor I am learning these two networks, correct? And in the same way from neighbor 2.2.2, from neighbor 2.2.2, what networks I am learning, what prefixes I am learning, these two prefixes. Getting my point? Okay, so till here everything should be clear to you guys. Now let's move to next part. So on router number 2, On router number 2 we are learning both 10.1.1.0 and 10.1.2.0, right? And their IBGP neighbors are advertising to each other, means router 2 and router 3, with after modifying next hop address. Now let me take you to router number 4. Or on router number 2 and on router number 3, what you can check that router 2 is advertising these 10 prefixes to their next neighbor, means router number 4 and router number 5 or not. Because on router number 2, so IP BGP summary, right? Router 4 is also my neighbor and router 5 is also my neighbor. How you will verify that these are IBGP neighbor or EBGP neighbor, right? You can run this command, so IP BGP neighbor, right? With the help of this command we can check. See, 1.1.1 external link means EBGP neighbor. After that, neighbor 4.4.4, or simply I can run this command neighbor and then ID 4.4.4. So see, this neighbor is my internal link IBGP neighbor, right? Same thing 5.5.5, this is my again IBGP neighbor internal link. Okay, now guys, I am going to run this command here, IP BGP neighbor and then IP BGP. So this is my BGP table, okay, and so IP BGP summary, this is neighbor table. So see, this router number 2 have learned how many prefix from router number 1? 2 prefix. How many prefixes from router number 3? 2 prefix. How many prefixes from router number 4? 0 prefix. And how many prefix from router number 5? 1 prefix, right? 1 prefix from router number 5. That means router 5 has advertised which prefix? This prefix to router number 2. Fine. Now on router number 2, I want to check what that router 2 is advertising 10 prefix 10.1.1.0 and 10.1.2.0 to router number 4 and router number 5 or not. So what command I will run here? So IP BGP neighbor 4.4.4.4 and advertise routes. So you can see router 2 is advertising these 2 prefixes to router number 4. Correct? This is also fine. Then I will check router 2 is advertising to their 5.5.5 neighbor or not. So yes, it is advertising to router number 5 as well, right? Same thing on router number 3. So IP BGP neighbor 4.4.4 and advertised route. Yes, router 3 is also advertising these 2 prefixes to router number 4 and to router number 5. Yes, it is advertising to router number 5 also, you can see. Fine. That means till here we have verified everything is correct, right? Now guys, I am going to take you to router number 4. On router number 4, first I will run show IP BGP command, right, to check BGP table, or you can run command show IP BGP neighbor 2.2.2.2 and received prefix, right? Received route, right? So you can see inbound, okay, leave it, you can simply run this command for now, because here you can see inbound soft reconfiguration not enabled, so you have to enable it, then you can run that command. Otherwise you can run this command route. So you can see router 4 is receiving these 2 prefixes from router number 2, but what is problem guys? These 2 prefixes are not best, these prefixes are only valid, right? Same thing I can do for which neighbor? For 3.3.3. 3.3.3.3. Yes, again I am receiving these 2 prefixes from my neighbor, but these are only valid, not best. And you know the reason why these prefixes are not valid, only not best, only valid. So IP BGP. See, first problem is what? Router 2 is advertising this prefix to router number 4 without modifying next hop address. So next hop is what? 1.1.1 over here, right? Maybe this next hop is not reachable from router number 4, right? And same thing is I think happening on router number 5 also. On router number 5, so IP BGP neighbor and 2.2.2.2, let's say what route. So you can see router 5 is also learning these 2 prefixes from 2.2.2, but these prefixes are only valid, not best, from 3.3.3 also, right? Only valid, not best. Now we need to find the reason why these prefixes are only valid, not best. For that, what I can do, I can open this network in detail. So IP, BGP, and then 10.1.1.0, right? If I will run this command, you can see over here what is problem. Problem is BGP routing table entry for 10.1.1.0/24 version. Okay, these are correct. Not advertised by any peer. Okay, see 1.1.1 inaccessible means from router number 4 1.1.1 is not accessible, right? Means this network 1.1.1 is not present in the routing table of router number 4, right? So this is guys problem. This is problem. And I think same thing is happening for other neighbor from 2.2.2 also. You can see this is from which neighbor 3.3.3 and this is from which neighbor 2.2.2. Both neighbor are advertising this network with next hop what 1.1.1 with 1.1.1 and 1.1.1 is not accessible from here. So IP route 1.1.1.1. You can see this network is not in table, right? So IP OSPF, because here we are running OSPF as a database, sorry, as a IGP protocol. So I am going to check so IP OSPF database. Guys, inside the OSPF database, we have router LSA of router number 1. We have router LSA for router number 1. If I will open it in detail, so IP OSPF database and then router LSA, right? And then router, let's say 1.1.1. I want to open the LSA 1 of router number 1 in detail, right? So yes, you can see we have this network in the database, but you know why this network is not available in routing table? Because in real time you will filter these prefixes on, you know, for router number 4 and router number 5, this 1.1.1 is unwanted prefix, right? Because router 4 and router 5 never need to forward traffic to 1.1.1, right? So because of this, maybe you are filtering 1.1.1 on these two routers, or maybe you are allowing only some specific prefixes on this interface and this interface and this interface. Like maybe you are allowing this network 2.2.2 and 3.3.3, right? So guys, here what I can do, I can tell to router number 2, brother, whenever you will advertise prefixes to router number 4 or to router number 5, because these are your IBGP neighbor, so please modify the next hop address. Please modify the next hop address. Or what is the other option? Here I can tell to router number 4, I can configure router number 4 in such a way so that whenever router 4 will receive any prefixes from router number 2, it will set next hop address what? The IP address which is running on this interface, right? So let me use the second method first, and then I will run next hop self command as well on router number 2, because next hop self command will work only on edge router, right? So guys, on router number 4, if I want to modify the next hop address for 10.1.1.0/24 network, then what I need to do? So IP BGP, you can see this network is in my table, right? But next hop is 1.1.1. And who is advertising this network? Router 2 and router number 3. Okay, so simply on router number 4, I can create one route map with name what? Let's say what? Next hop, right? And then we can define a sequence number, let's say what? 10. If I am not going to match anything, it will match all. If you want to match something, what you can do? You can create one access control list to match the prefixes. But here I am not going to define any match, so it will match all. And then here I am going to say what? Set IP next hop is the IP address of this interface, right? This interface. So on router number 2, let me verify what IP address is running over here. So IP interface brief exclude unassigned. So IP address which is running on fast Ethernet 1/0 is 24.1.1.2. So on router number 4, I'm going to say set next hop is 24.1.1.2. And now I am going to apply this route map in BGP with neighbor 2. So router BGP 65,001, and then I am going to say neighbor 2.2.2, and let me call to route map for with this neighbor. Route map name is next hop. Let me verify the name because this is very important. Okay, name is correct, next hop, right? And then guys, direction. So in direction, now if you will run command here, clear IP BGP star soft in, and after that if you will check BGP table, so IP BGP, you can see this prefix now 10.1.1.0/24 is best via router number 2, because via router number 2 next hop address is what, now 24.1.1.2, right? So here again you are not able to see that this prefix is best through which neighbor, from 2.2.2 or from 3.3.3. You are only able to see what next hop address, right? So through next hop also you can verify, you can identify that I am getting this prefix from which neighbor. But again, if you want to check the detailed information, simply you can run this command. So IP BGP and then network 10.1.1.0, right? So you can see from router number 3, still you are not accessible to 1.1.1. Still you are getting prefixes with next hop what 1.1.1, which is not accessible. But from router number 2 next hop IP address is what, 24.1.1.2. That's why now 10.1.1.0 and 10.1.2.0 is best via router number 2. So IP BGP, right? So both prefix now 10.1.1.0 and 10.1.2.0 are best via router number 2, right? Or I can say neighbor 2.2.2.2 and route. So from this neighbor you can see I am getting these two prefixes which are valid as well as best. But again from 3.3.3, from 3.3.3 these prefixes are not valid, sorry, only valid, not best. Okay, so this is first option. But as my router number 2 and router number 3 is edge router, so I can run next hop self command there, right? And on edge router guys, in real time also you will always run next hop self command. So simply what I am going to do, I am going to remove route map configuration. I see before removing the route map, I want to show you BGP table of router number 5. So IP BGP, see on router number 5 still these prefixes are valid, not best. Clear IP BGP star soft in. See, getting my point? Because router 4 is not advertising 10 prefixes to router number 5, but we have one IBGP neighborship here. So IP BGP summary, router 4 is also neighbor, receive prefix 0. Now can you let me know in the comment section why router 4 is not advertising 10 prefixes to router number 5? The reason, if you don't know guys, please let me know. I don't know, right? But if you know, please let me know the reason why router 4 is not advertising this prefix to router number 5. I'm going to give you some hints as well. See, router 4 is receiving 10 network from their IBGP neighbor, right? IBGP, and router 5 is also their other IBGP neighbor, right? Now if you have knowledge of BGP, you can let me know your answer in the comment section, that why router 4 is not advertising 10 prefixes to router number 5, and what feature here I need to configure so that router 4 should advertise it to router number 5. Okay, so still you can see communication will not happen from here. Again I am going to ping from router number 1. I am going to ping this IP address, ping 192.168.10.254 and say source is 10.1.1.1. Ping is, sorry, 254. Ping is not working because still router 5 don't have route for this two network 10.1.1.0 and 10.1.2.0. Simply I can do one thing. On router number 4 I can run one command, router BGP. I'm not going to explain you this command because this is my question, right? I'm expecting answer from your side in comment section. But here I am going to run one command, right? Not going to explain you, only I'm going to run this command, right? Router BGP 65001 and then neighbor 5.5.5.5 route reflector client. Now let me take you to R5 here. See, so IP BGP. Okay, now you can see this network is best. Okay guys, so from router number 1, now if I will ping, you can see ping is working. Now there is reachability, right? From the second network LAN 2 also you can see ping is working. But I am going to remove this command from router number 4, router BGP 65001, and say no to this command first. Okay, and then I'm going to remove route map configuration as well, right? So do so run a section, let's say BGP. I'm going to remove this command. Where is my command? Route map, this one. Okay, so say router BGP 65001 and then no, and let me paste this command over here. Now again clear IP BGP star soft in, right? And so IP BGP. Again you can see these two prefixes are not best, only valid. On router number 5 also so IP BGP. Got it? So what I need to do, guys, now hope scenario is clear to you, problem is clear to you, right? And the how to fix it is also clear to you. Simply on router number 2 and on router number 3 I can run one command. That command is next hop self for both neighbor, for router number 4 and for router number 5. I can tell to router number 2, brother, whenever you will advertise prefixes to router number 4 or to router number 5, please modify the next hop address, right? The reason is what? If you will not modify the next hop address, this router will get prefixes with next hop port 1.1.1, 10 prefix and 10.1.1.0 and 10.1.2.0, which is not accessible from these router, from router number 4 and router number 5. So please modify the next hop. Please set next hop 2.2.2 or the IP address which is running over here. And same thing I will do on router number 3 also. I will tell to router 3, please, whenever you will advertise prefixes to router number 4 and to router number 5, please modify the next hop address. Because you are advertising prefixes to router number 4 and router number 5 with next hop 1.1.1, which is not accessible from router 4 and 5. So please modify the next hop. So simply what I can do on router number 4, sorry, on router number 2, I can say router BGP 65001 and then say neighbor 4.4.4.4 and what? Next hop self. Okay. Now on router number 4, so IP BGP, clear IP BGP star soft in, and then you can check the BGP table. See, next hop 2.2.2, right? Still router 3 is advertising with next hop port 1.1.1. So I need to run same command on router number 3 also. Router BGP 65000 and then 65001 and then neighbor 4.4.4 and what? Next hop self. Now again on router number 4, let me clear the BGP table and then I can run so IP BGP command. Yes, now you can see both routers are modifying next hop address. And guys, best is via which router? Best is via router number 2. Again, this is a question for you. If you are good familiar with BGP attributes, if you know the BGP attributes, please let me know why best is via router number 2, why not via router number 3. Both are there, iBGP neighbor. Okay, and if you don't know the BGP attributes, then guys, please watch my BGP attributes video, right? After watching that video, you will become master in BGP attribute. You can perform path manipulation, you can perform route filtering. Getting my point? So here we have modify the next hop address for neighbor 4.4.4 on router number 2 and router number 3. But again on router number 5, so IP BGP next hop is still what? 1.1.1. So I have to tell to router number 2 and router number 3 that please modify next hop for 5.5.5 also, right? You have did it for 4.4.4. Do same thing for 5.5.5 also. So neighbor 5.5.5 and next hop self. On router number 3 also neighbor 5.5.5 next hop self. Got it? Now on router number 4, so IP BGP fine. On router number 5, so IP BGP clear IP BGP star soft in, and now you can see so IP BGP. Yes. Now 10.1.1.0 and 10.1.2.0 both networks are best as well as valid. Best is via router number 2 and only valid via router number 3, right? And guys, if you are not, if you are not feeling confidence in BGP, like you are thinking that my BGP concept is not, strong or not cleared, then I have one separate playlist on my YouTube channel, BGP CCIE. There are few videos, just you need to watch those videos to master BGP routing protocol. Okay, because such type of playlist is not available on YouTube, guys. So I have created that playlist only for my subscribers so that my subscriber can learn BGP from basic to advanced. Everything's are there about the BGP, like CCNA to CCIE, CCNP to CCIE. Okay, now hope this is clear to you, and now you can see, guys, on router number 1, so IP route. So IP route, we can say BGP. So through BGP I am learning this network over here on router number 1, and on router number 5 I'm learning so IP route BGP, these two networks through BGP. And next hop IP address is 2.2.2.2, right, which is my primary path. And again, if you will verify the connectivity, like ping 192.168.10.254 and say source 10.1.1.1. See, sorry, 10.1.1.254. See, ping is working, right? So now we have fixed the problem. Now everything is working fine. Hope it is clear to you guys and this video was helpful for you. If yes, if you have learned something from this video, please hit on like button. If you want any more video on any other topics, please let me know in the comment section. We will meet soon in next video. Till then, stay safe. Bye bye. That's all for today, and thanks for watching.